hit record. And now you
Oh,
all
wow.
just heard that. It's very official sounding. And Mr. Schneider, take it away.
Yeah, well, I want to make sure that I feel like it's going to pop up on my screen. Yes, I need to continue that so it actually can be recorded. Okay. So howdy, y'all. I am Garrett Schneider. I'm a math teacher at Noblesville West Middle, sixth grade. And here we go. If you have any questions at all after this, or maybe you're watching a recording or something like that, you can feel free to email me to school, or if you follow me on Twitter, it's the @numberpunk, all one word, all lowercase. So first off, I just want to kind of know where people are coming from here. If you are watching this and you're available, like, could you just type in are you elementary? Are you middle? Are you high school? Are you more of like a coach role? Like, where are you at? If you want to type that in just so I can see it in the chat, that could be super. Elementary coach. Thank you, Miss Jensen. Fourth grade. Nice. Okay. Awesome. Middle school. Super. Yeah. So what I'm going to be talking about today is going to be kind of going from just kind of talk about multiplication and division strategies and all that kind of fun stuff. Because what I found is, so this is my end of my 11th or 12th year teaching. I did 7 years in high school in Tennessee, and this is my end of my 4th or 5th year here in middle school. And what I found is that in high school, I was like, you guys got to start thinking about this work. You got to be thinking about it. And they're like, okay, tell us how to think and tell us what ways we need to think. And then we will do our best to think in the exact same way that you need to answer the question correctly. And I was like, okay. And then when I came to middle school, I was like, okay, let's get to thinking. And I found that if I gave them a big problem, I'm going to write it on my screen here for an example. Let's say I gave them something like, I don't know, 99 times 34, like a nice gnarly problem like that. And they'd look at it and they'd be like, okay, 99, the bigger number always has to go up top for some reason, and then 34, and they multiply it, and then they'd kind of freeze. Some of them would get it. Some of them could do these steps. And some people would be like, and I'd be like, well, what's the problem? And well, I forgot, after some coaxing, they'd be like, I forgot what 4 times 9 is. And I'd be like, I don't know how to help you with that. Just know it, know your math facts. And when I was talking to parents, they'd be like, how is my son, how's my daughter struggling? And I'm like, they got to know their math facts. And then that was my answer for everything. Know your math facts, know your math facts. And then I realized through this kind of some training and some books that I've been reading that that's not a helpful way to go around it. Because let's say they know their math facts. In a perfect world, every kid knows their math facts. They can do 1 to 12, no problem. So when I give them a problem like this in a perfect world, they should be able to do it so well that they won't even think about it. And that's not a good place to be. You don't want your kids not to think about math. You want them to reason about math. You want them to be able to pull stuff from it. And then what if they get really good at this multiplication by this way? Or you have lattice as well. Let's say you get really good at the 99 and the 34, and then you got the lines and the lines and the lines. And then let's say they get really good at that. Where does that lead them? What skills does that strengthen? It strengthens them being able to follow steps that they don't understand. None of my students can tell me why either of these methods work. What does it mean? And then that becomes dangerous, because if I add a decimal point here, then they think they don't know how to do it. They got to figure out a whole new set of steps to kind of maneuver around. And so what we're doing is we're teaching these kids to kind of follow these steps and to follow like to come in and be like, listen, I don't know this stuff. You got to teach it to me. And then they'll learn this, and then they'll think that if you switch it up a little bit, they have to learn a brand new series of steps. They don't get the beauty that math is all connected. And so, yeah, so that's why I'm kind of talking to you about this. So let's kind of talk about something else, something a little less confrontational. Let's talk about gum. I like gum. So here's a really great thing of gum. Anyone remember? Type yeah if you remember this. Do you guys remember fruit striped gum? Anybody? Yes, yes. Like that was my jam. It was super cheap and flavor would last about 5 seconds. And then I could like spit it out and get a new one in. And yeah, 30 seconds of flavor. Thank you. And it was like delightful. But what I loved about it is for about $1.05, I could get a ton of gum. I mean, for me, it was a ton of gum. Like it would last me like a whole day, the whole pack. So how many sticks are in this pack? Who could tell me how many sticks are in this pack? Use your investigative skills. 17, perfect. Yeah, 17, 18. Yeah, if you look, we got it right here. We got 17 sticks of gum in this beautiful pack. So let's start doing some math with that, okay? So we know one pack is 17 sticks. Here, let me kind of organize the thinking here. Otherwise, I'll get lost. I get lost very easily. So let's say we have a pack of gum, and we want to know how many sticks are in it. Okay, so we know that one pack of gum is like 17 sticks. Who can tell me how many? What if I had 2 packs? Like how many sticks would be in 2 packs? If I know one pack is 17 sticks. Whoa, that was quick, Susan. Do you want to unmute yourself and kind of tell me how you thought about it? Like, how'd you think about two packs with 34 sticks?
I just did 17 plus 17. I know 7 7's 14, and I have 3 10s, or 2 10s, and 7 7's 14.
Oh, that's awesome. Thank you. So you knew that one pack plus another pack gives you 2 packs, right? And then you did 17 plus 17 to get that 34 sticks, right?
Yeah.
Awesome. Did anybody do it differently? Did anybody think about it differently? If you did, just unmute and talk to me about it.
I just added 10 to 17 and then added 7 more.
Oh, awesome. So you kind of added it in chunks, right? So you did 10. So you did 17 plus 10, because that's kind of easier to do. To get 27, then you added 7 more. I love it. Did anybody like, yeah, we'll keep it like that. So yeah, so now let's say we have 2 packs. That's cool. What about, who can kind of tell me what 4 packs would be worth? How many sticks would be in 4 packs of gum? You can just type your answer in. How many sticks would be in 4 packs of gum? Okay. Okay, cool. That was quick. Let's see here. Ms. Ramirez, do you feel comfortable sharing about how you got 68?
Yeah, so I just did 10 times 4, which is 40, and then 7 times 4 is 28, and then I did 28 plus 40.
Can you do it one more time? I'm like, it's still early in the morning for me. Can you kind of like explain it again just a little bit slower so I can kind of keep track of your great thoughts here?
Sorry, so I did, I basically separated 17 into 10 and 7.
Okay.
So I did 4 times 10, which is 40.
Yeah.
And then 4 times 7, which is 28.
Yeah.
And so then I did 40 plus 28.
Oh, groovy. So you knew how many sticks were in 1 pack, and you times that by 4. Awesome. And then you did 17 times 4 by breaking 17 down to its like different pieces. And then you kind of put it back together by adding. That's really cool.
Now that I
Did
think
anybody
about it,
think?
sorry.
What's up? No, what were you going to say?
Now that I think about it, I could have just done 34 times 2 and that'd be way easier, but my brain did not do that.
That's okay. That's okay. Oh, so you're saying that you could have taken what you already knew, the 2, and then doubled it to get 4 packs and then doubled 34 to get 68? Is that what you were saying, Ms. Ramirez?
Yeah, just when I looked at it, when you said it, I just did 17 times 4. And then now looking at your work, I could have totally done that. It would have been easier.
Oh, okay. That's cool. I like easy. I told my kids that by doing math, it's just, you just got to do the easiest thing that you can. And maybe it takes time to learn the easiest thing. But like, yeah, work smarter, not harder. Okay, what if I'm really greedy here. I want to have enough gum for a week. I want to know how many sticks are in 8 packs. How many sticks would be in 8 packs of gum? You can just type it in when you get it. We got 544. We got 136. Okay. So did anybody use the problems, like the information that you already had to get that 8 packs of, it's okay, Susan, no problems. But did anybody use what you already knew to kind of make this a little easier on yourself? If you did, feel free to unmute and share. I'd love to hear what you did.
I did. It's Julie Jensen.
Oh,
I
cool.
knew
Thank you.
that 4 packs was 68.
Mhm.
So I knew if I doubled that, I would have 8 packs. So then I doubled 60 to get 120.
Yeah.
And then I doubled 8 to get 16. And then I combined 120 and 16.
Oh, that's groovy. That is a really clever way to do that. That's really neat. So you got 136. Man, doubling 68. How else can we think about doubling 68? Like, I wonder, like, 68 is such a weird number, you know? Like, we could do what Ms. Jensen did and do 60 times 2, right? And 8 times 2. So we got what, 120, and then 16, and then we got 68 times 2. This is what you said you did, right, Ms. Jensen?
Yep, exactly.
Yeah, cool, yeah. That's really great. Did anybody think about doubling 68 a different way? I'm just curious. I really love the idea of like doubling and having things. So like anything that I could add to my repertoire, I'd be totally down with. Anybody else think about doubling 68 a different way? No, that's cool. So now, what about this one? What if I want to share it with my sister? She kind of likes gum just a little bit. So what if I wanted to know 10 packs? What are some ways that we could think about 10 packs of gum? So type in your answer when you get it. Okay, sweet. I'm just going to move this a little bit so I can get some space here. Don't want to run out of it. So how do we think about 10 packs of gum? Who wants to unmute and kind of share? How did we think about 10 packs of gum? We got 170. That is awesome. How do we think about it? Who wants to share that?
Honestly, I just think 17 times 10.
Yeah, right.
That's all I've
Hey,
done.
no, that's great. Use what you know. You
Yeah.
know your times 10s. Times that by 10 to get 170. I wonder, Is there another way we could have got 10? Could we use any of the stuff that's already there to maybe figure out another way to get 10? I want you to look at that for a second and try to figure that out. When you see something, just type like a Y in the chat or something so that we can kind of know. Is there another way we could use this information to figure out 10 packs of gum? Miss Kenworthy, are you okay with sharing?
Sure.
Okay.
Well, I saw 8 packs is 136 and 2 packs is 34. So we could do 136 plus 34.
Oh my gosh, we could, couldn't we?
Yeah.
That's cool. And we got the same answer, right?
Right.
Oh my gosh. So it's kind of like whatever strategy is kind of cool. Okay. Okay. Nice. Okay. Now, oh, I bought too much gum. I have too much gum. How many sticks would be in 9 packs? Type your answer when you get it. How many sticks would 9 packs of gum give you? Oh my gosh, that's quick. Julie, did you just do like 17 times 9 really quick?
Absolutely not.
What?
I subtracted 17 from 170.
You can do that?
I did. Yeah.
Why? Why'd you do that?
Because I knew it was 1 pack less than 10, so I took 1 pack away from what I had.
Oh, is that a little quicker than doing 9 times 17?
For me, yes.
Yeah. Yeah. Okay. Okay. Let's kind of run with this for a second. You are such a good thinker. What was the answer again?
153.
153. Thank you. So you saw that. Wait a second. All I'm doing is I'm just getting rid of 1 pack, which is the same thing as 17 sticks. And I would much rather subtract than do a big multiplication problem kind of any day of the week. Even if it's like, it's just a little subtraction. Okay, so now I'm going to take a pause here. Like, I want you all to admire the math that you were doing, like right now. You were able to say, listen, I could just treat this as 1, 2, 3, 4, 5, 6 separate math problems. Or I could try to reason and use what I already know to try to make this easier on myself. This is kind of the core of what I'm talking about here. It's developing strategies. It's using strategies and using the best strategies that will work for you at the time. And then my goal as a teacher is to be promoting different kinds of strategies. So it's kind of broaden your worldview. Okay, now my mom, or my grandmother really, gave me a birthday card, and in it was a ton of money. So I'm gonna buy a lot of gum. I want to know how much, like, what if I have 100 packs of gum? Thank you, Miss Seago. If I have 100 packs of gum, how many sticks would that be? Go one. Awesome, awesome, awesome. That's because we know how to multiply by 100, which is awesome. Something that our kids don't quite, are hit or miss with, but that's what teaching's for. But yeah. So yeah, we totally just do like, let me click the color thing. 1 times, 100, and then 17 times 100. Oh wait, my grandmother didn't give me this much money. I'm sorry, I made you do all that math for nothing. I have enough for 99 packs. Can you just tell me? It'll take you a while, I understand, but like I have 20 minutes left. So if you could just tell me how many sticks would be in 99 packs, I would really appreciate it. So I know how many friends to invite to a random party that I'll have, and I'll give them a go. So just type it when you got it. I mean, I got 20 minutes, so we got time. Okay, we got 3 answers already. Okay, so I'm just gonna like read your mind here. I know we're all math teachers, or we all know math, so we all kind of know what to do, right? So just give me a Y or an N if I'm doing this right. So what you were thinking was, you're like, okay, I got 99 times 17, right? And then you do 7 times 9, which is 60. Wait, no, I always mess that up. 3 with the 6, 63 plus 6. Well, I'm not done yet, Susan. No? Okay. You're probably elementary, right? So you probably
Right.
did you did this.
No,
What?
no.
What'd you do?
I just subtracted 17 from 1700.
Oh, we can do that, can't we? Because we know that if we take 1 pack away, that's 99. So 17 from 1700. What'd you get, Susan?
1683.
Oh, that sounds pretty good. Wait, wrong purple. 1683. Yeah. You just did 99 times 17 in a fraction of the time that it took. And all
True.
you needed to know for that is that you could jump up to 100, and then you could take 1 away to get 99.
Yeah.
This is the permission that we can give our kids. When I was doing this with my students, I swear, the rule followers in my class were like, I don't think I'm working hard enough for this. I don't like it. But the students that have struggled consistently in math, because they always forget the algorithms, they always forget the steps, they always forget where that you got to put a 0 in when just to have 1 in. They were like, I'm allowed to think like this. Like, this is cool. I can do this. And I actually saw them succeed, because like multiplication like this, it builds your multiplication skills. It builds your thinking skills, but it builds your proportional reasoning skills, which is so, so important for middle and high school. So let me kind of go to this next part here. There's an article from The Guardian where they looked at the most you messed up multiplication facts. And surprisingly, 8 times 6 was the most missed, with 62.5% of the people getting it wrong, followed closely by 6 times 8 with 60%, which is like crazy. But my old Garrett would be like, well, they got to memorize it. Like, that's what summer's for, right? Just like a little bit a day. 1 week you do the 8s, 1 week you do the 6. Like, it's not hard, But what that does is that takes joy of math away from kids. And they come into class exhausted because they already feel like they don't get it. So instead, what if we thought about it a different way? What if we said, hey, wait a second. I don't know what 8 times 6 is, but we can give them a strategy to figure it out. So if you don't know 8 times 6, who can kind of type in maybe a multiplication with an 8 that maybe you know? If you have a struggle with 8 times 6. Ooh, 8 times 10? That's a groovy one. We could do that. 8 times 5? We can do, let's do 8 times 5, and then we'll see what we got. So kids are usually pretty good with the 5s. So because they can count 5, 10, 15, 20. That's cool. So we don't know 8 times 6. And that's okay. I tell the kids, I get that way. It's like I'm in a white room with no windows, and I have no idea how to get out, because we're not given skills to know what to do next other than adding 8 6 times. So if we do what Ms. Kenworthy suggested, They know what 8 times 5 is. That's 5 eighths. That's going to be a 40, yo. And if I have 5 eighths and I want 6 eighths, y'all, how many more eighths do I need?
8 more.
Yeah, well, one more to get to 8, but I know what you're saying.
One more, yeah.
And now they have a tactic. They have a strategy to get 8 times 6. And it's a good strategy. It's much better than adding 8 6 times. When I go by students' desk and I see this, I'm like, okay, I need to stop for a second and help you out, because this is not a good strategy for you. I mean, it's a good strategy for you right now, but we can really take it to another level and it can blow your mind. So let's see here. Now, I promised multiplication and division. I promised all this stuff. So let's kind of get into it. This is like the taste of what we can do. Okay, but let me show you kind of the practice. Let me show you what else we can do. Let's say we have this. Let's say we have a bag of candies, and each bag has 15 candies in it. And what I want to know is how many candies are in 21 bags. And we can totally do 21 times 15. And that's cool. But what if we didn't need to? What if we could find this by reasoning and thinking? So I'm just going to kind of guide through this faster than I would normally, because y'all are teachers and you all are semi-good at math, and I don't want to run out of time here. But like, what you have is, you know that you have one bag with 15 candies in it. And your goal, and this is a ratio table, I love ratio tables, it increases proportional reasoning and it organizes the kids' thoughts. They do so much great thinking, but it's lost because they write numbers all over the page. If they can organize it in just a simple table, it'll save them so much time and effort. So let's say I want to get, I don't know, I'll put it here, 21 bags. I know one bag. I could always do 1 times 21, but that's a lot of work. Can anyone suggest a smaller jump that could maybe get me close to 21 bags that I can kind of do relatively easily? This is a big jump I'm asking y'all to make. Like, what can we do to figure out, what's something we could do to figure out 21 bags? What's like a little step we could make? 20? Ooh, 20 is a good one.
Or even 10.
Or even 10? Yeah, let's take a babier step first, but I love 20. We're going to get to 20, trust me. So if I have 10 bags, how much candy would be in 10 bags? We're all friends here. You can shout it out if you don't want to type.
150.
150. Can I use 10 bags then to get 20 bags?
Yeah.
Yeah, but doing what?
Add another 150.
Yeah.
For 20 bags.
Oh, wait. I can't get from 20 to 21 by multiplying. That's a lot of work.
Mm-hmm.
How can I get to 21 now?
Add one more bag.
Oh, yeah, we can do that. We can say 1 bag plus 20 bags is just 21 bags. So that means 15 candies plus 300 candies is 315 candies. We've reasoned our way through doing 21 times 15. We've broken it apart. We've taken what the kids know, what they're given with, and we can scale it up. What's awesome about this is that this works for reducing fractions. This works for anything. This works for decimals. Let's say I have 1 banana that's 38 cents a pound, but I don't want 1 banana. This is what blew my mind. Just a heads up, when I learned this, it blew my mind. I was like, what? And I want to know, I'm going to write it at the end here because I don't know how much space I'll need. And I want to know 4.2 pounds. So now this is decimals, right? So you got to do what? 4.2 times what? 0.38. And then you got to multiply it. Then you got to add the decimals. Kids love this, right? They live for multiplying decimals. That's like everybody's favorite unit to do. And if you're upper middle school and high school, it's everyone's favorite unit to review is multiplying decimals. But watch this. What if I didn't want 4.2 pounds of bananas? What if I just wanted 4 pounds of bananas? Is there an easy way, like even in a couple of steps, for me to get to like 4 pounds of bananas? Can anyone kind of voice that or type it in? It's up to you. Is there a way to think about 4 pounds of bananas? Is there a step I could make to get to 4?
Okay, here, I'm going to go out on a limb here.
Yeah,
When I
sure.
look at, so when I think 38, I always have to think, so 38 cents plus 38 cents would be 76 cents. And then I know,
That's 2 pounds, right?
yes. And then if I want to double that, I start to think quarters, and I know 75 plus 75 is $1.50, and then I just need to add 2 more cents.
That's awesome. That's how we want kids to think. That's amazing. And we can encourage them and teach them that. It doesn't have to be stack it up, but don't line up the decimal places only for addition and subtraction. And when you multiply, don't forget to add, do little butt cheeks. Like make sure you got 3 little butt cheeks in there when you move that decimal point over. We don't have to do that. We can say, listen, I don't know 4, but I know 2 by doubling. And then I could double it again. And if 76 is too hard to double, then just do 2 75s and add that 2 over. That's perfect. That's the thinking that we want, okay? So what's 76 doubled again?
$1.52.
Yeah. And how far are we away from 4.2 right now?
2/10.
Yeah. Oh my gosh, look. We could take our 2. Oops, I hate that. What's 2 divided by 10? Anybody know? 2 divided by 10?
2/10.
Yeah, 2/10. And then 0.76 divided by 10. That's just 0.076. We have everything that we need here. 4 plus 0.2 is 4.2. 1.52 plus 0.076, that's 596. Y'all, we can reason through decimal multiplication. That's insane. I only got 7 minutes left, so I got to skip a couple things. I promise you division. Oh, this is a good one. We have 1,364 divided by 31. That's a great problem. Everyone loves that problem, right? Or actually, how about we take an I learn kind of question? Let's do 9,660 divided by 420. That's a great problem, right? So we start off with like 420. And I want to know how many give me 9,660. How many of those can I fit into 9,660? When the students are good enough about thinking about numbers and scaling, they can say, I don't know, and that's okay. They can say, wait, how about I just get close to it? Is that good enough? And yes, it is. What if I just times that by 10? 10 420s is just 4,200. I'm pretty close. I wonder, do you think we can double it? Like, if I want to get into 9,660, you think we can double 4,200? I think it'll still fit in. I bet it'll get us close. So double 10, that's totes 20. So what's 4,200 doubled? Well, that's going to be, sorry, I'm running out of time. I can't, I got to kind of go as we go. 8,400. Oh man, we are so close. Okay. When we're this close, you just kind of got to ask, like, how far are we away? We're so close. We have 8,400 and we want to get to 9,660. How far are we away? Well, we are about, let me do the math. Yeah, right, around 2 away. More specifically, we are 1,260 away. Or, as Ms. Kenworthy said, well, we're at least 2 away. That's awesome. Let's roll with that. So we know, oh, thank you, Ms. Siegel. So we know that, hey, 2 is 840. If 2 is 840, because we kind of can do 20 divided by 10 if we want, then, well, that's not really what we need, but what about 3? 1 plus 2 gives us 3, 420 plus 840. Oh, wow. That is 1260. We're thinking about numbers. We're being fluid with our numbers. We're creating students that are comfortable with thinking about doubling and halving and timesing by 10 and dividing by 10. And we're giving them permission to move fluidly with our numbers and then to get, well, this plus this gives us this. So 20 and 3, that gives us 23. Okay? It's us moving around with our numbers. It's us being comfortable with this and putting it, and allowing, and then just showing them a model and different strategies to kind of get us there. Sorry, we're running out of time. I had some decimal with division 2, lots of good stuff. I learned all this stuff from this book, from these books. And if you're interested and you're like, yes, this is my jam now, I want to learn more, the woman who wrote those books is actually doing a free workshop in the end of June. And it's transformative. I love it. This is all I'm going to be doing next year. I already started it this year. It was great. But there's this. What are some thoughts we have in our few minutes? Any thoughts, any questions, anything? I'm opening up to anybody either in the chat or audio if you're interested.
I have a thought. This is Susan again.
Hey.
Hi. Thank you for all of your information. And I love working with numbers and enjoy that with students as well. Do you have a foundation for getting back to multiplication facts? I love for kids to at least know like 2s and 5s and 10s, because you can go so much with that. And I know there is, this strong push in the education realm of not mastering our facts, and yet in the parent realm, I hear I want my kids to master facts. How do you go about chatting with those parents?
So here's a couple of things. One, I think it's so important the students master facts. I am 100% on board with that. What I'm not 100% on board with is getting like a giant, like a giant times table tests. Because what that does is if they get good at that, that only lives in the short-term memory. That doesn't live in long-term memory. They're not thinking their way through that. They're not reasoning their way through that. I want the students to master their facts while reasoning through it. So let's say, I think 2s and 10s are super important. And 5s are important too, but we can get to 5s by reasoning. Like, you don't need to know your 5s if you can reason your way through them. So let's say we don't know what like 6 times 5 is, you know? Oh, thank you. I bet we could figure out 6 times 10 and then cut that in half. That's cool. If they can reason their way through it, that's what makes me happy. And you get mastery the more you reason your way through it, and it's more stored in your brains.
Okay, makes sense. And I do really love playing with numbers, and I think that it is inspiring to kids too. It helps them to go farther.
Exactly. And what's really cool is not only is playing with numbers, but also teaching them strategies to play with numbers. Because like so many times when I was looking at number talks and stuff, it's like, hey, here's a number. What do you think about it? And that's great. And they have lots of thoughts. But then you need to focus them on different strategies to really help them with that. Right. These books help give those strategies. They have like different tactics that you can use and different tactics that you can learn. And I mean, I love them.
Fantastic. Thank you so much. And I also love the use of the table. I haven't used that other than when it comes up in the book, you know, in our journals or whatever. But I like how you use that to help them use those strategies.
Yeah, it's a great way to organize your thinking. And if they know how to use a table in elementary, it saves middle school teachers so much work because it's all ratio and proportions. You can do fractions with, I mean, there's so much. My kids are like, oh, ratio table. And then at the end of the year, they're like, yes, I know how to do this.
Awesome. Thank you so much.
No problem. Thank you. And I think, have we surpassed our time, Miss Ego? Are you nodding? You're on mute. I can't tell.
I was just talking. I forgot I was on mute. Yes, we are over at 11. Is that right?
Oh, I believe so.
Yeah.
So yeah, I'm going to stay on for as long as people want to talk or whatever.
Awesome.
But yeah, if you need to go, that's cool. Thank you so much for coming. And if you have any questions at all about any of this stuff or these strategies or sharing stuff or whatever, shoot me an email. Get me on Twitter, whatever, and I'd be more than happy to talk to you about it. This is a fun journey. No problem.
Thank you, Mr. Schneider. I'm going to go ahead and stop the recording. And then, like Mr. Schneider said, if anybody wants to hang out, he's available.
Yep. Thanks,
All right.
Ms. Ego.
Thank you.